Well, hello everyone. Good afternoon. Many thanks for joining us today. My name is Ines Jimenez. I'm a program officer at Climate Strategies, as well as the communications lead for the Co-Create project. On behalf of our consortium, I'd like to welcome you all and thank you for joining this opening session of the Co-Create webinar series. Through this series, we aim to share the latest research on SRM research governance, that is solar radiation modification, in an accessible and engaging manner, and in doing so to facilitate public engagement in an informed and inclusive way on this important yet very contested topic. Before going any further, I'd like to give the word to our colleague François Bougel from Perspective Climate Research, who'd like to share a bit on who we are and what we do within the Co-Create project. François, over to you.
Thank you, Ines, and good afternoon, everyone. My name is François Pougel. I'm a senior project coordinator and a consultant with Perspectives Climate Research. So we are the coordinating organization of the Co-Create project, and it is also my pleasure to welcome you in this webinar. So we're here today to discuss one of the most controversial areas of climate policy. This is solar radiation modification, also known as SRM. This term refers to a set of climate intervention techniques that aim to limit global warming by slightly reducing the amount of sunlight that would be reaching our planet. It could be very helpful in reducing some of the impacts of climate change, but it could also come with considerable uncertainties and risks, both physical and social-political. As temperatures start exceeding the 1.5C threshold, it seems increasingly important to better understand how these risks and uncertainties would compare to those brought about by climate change. So this is why there is a growing debate on whether SRM research, including field experiments, may be warranted to reduce some of these uncertainties and lower the probability of problematic outcomes. At the same time, our current governance systems don't seem ready to inform decisions on whether and under what circumstances SRM research and experiments may be warranted from scientific and societal viewpoints. And this is where the Co-Create projects come into play. So we are a 3-year action funded by the European Union, and we are seeking to address this very issue through an interdisciplinary assessment of scientific, ethical, and governance considerations. We aim to support decisions on whether or not and under which circumstances SRM research and experiments may be warranted from scientific and societal viewpoints. I'm not going to hand over the floor back to my colleague Ines, who will introduce today's speakers and their presentations. Thank you, and I hope you will find this webinar helpful to think through these very thorny issues.
Perfect. Many thanks, François. So yeah, we have a very exciting agenda today. First, we'll hear from Bedouin Monroche from UCL, who will introduce the topic of SRM, its science, risks, and potential for climate stabilization. We'll then hear from Julie Winders from Trilateral Research, who will provide an overview of legal frameworks on SRM research governance. And then we'll hear back from Ben again as he presents his recent work on case studies for hypothetical field tests and related activities to inform conversations on SRM research governance. After these presentations, we'll be joined by Jesse Reynolds, Chief of Staff at the Degrees Initiative, who will share his thoughts on the research presented today. And then we'll go into a Q&A session where you're most welcome to share your thoughts and questions on this topic. If any questions come up during these presentations, please don't hesitate to share them already through the Q&A chat, and we'll do our best to come back to them at the end of the event. So, without any further ado, I'd like to give the word to Ben for the first presentation of this event.
Brilliant. Thank you so much, Ines. So I'm Ben Roach from UCL, and I'm going to start with a high-level overview of solar radiation modification, or SRM, which should act as an introduction for those who may be less familiar with the topic, and hopefully should help set the stage for why the Co-Create program is examining the governance principles and guidelines for responsible SRM research. So SRM is an approach to temporarily reduce global temperatures, while long-term solutions, namely emissions reductions and carbon dioxide removal, are developed and scaled up. As shown in this diagram, the theory is that SRM could help to shave the peak of climate impacts in the short term as these long-term solutions are developed and expanded. Next slide, please. So the reason why interest in SRM is growing is primarily due to the fact that we are experiencing accelerated warming, with 2024 being the first year where average global temperatures exceeded 1.5 degrees Celsius above the pre-industrial level, and likely the warmest in 120,000 years. But more concerningly, this is due to the higher than expected radiative imbalance that is currently occurring, as highlighted in this graphic by Jim Hansen et al. 2025. As the dashed red arrow indicates, our current radiative forcing trajectories track RCP 8.5, meaning about 4 to 5 degrees Celsius of warming by 2100. And we are currently significantly overshooting RCP 2.6, represented by the dashed green arrow, which would mean about 2 degrees Celsius of warming by 2100. Consequently, whilst no credible researchers are currently calling for SRM deployment, there is increasing interest in developing our understanding of the science should we one day be faced with the prospect of needing to consider SRM as part of an emergency response toolkit. Next slide, please. SRM techniques aim to either reflect more incoming shortwave solar radiation or to enhance the escape of outgoing long-wave terrestrial radiation, both of which would help reduce the amount of energy retained by the Earth system. And here you can see the three main SRM techniques. First of all, we have stratospheric aerosol injection, or SAI. So this technique involves releasing sulfate particles into the stratosphere to reflect more sunlight. And this aims to mimic the cooling effects observed after large volcanic eruptions. Secondly, we have marine cloud brightening, or MCB. This technique would aim to inject sea salt aerosols into the lower atmosphere, where they would act as condensation nuclei and help to form more numerous and smaller cloud droplets, thereby increasing the reflectivity of marine clouds through the Toomey effect. And finally, we have cirrus cloud thinning, CCT, or mixed phase cloud thinning, MCT. And so these two techniques aim to release particles into the upper troposphere that would encourage ice crystals within these clouds to grow larger in size and fall out more quickly. In so doing, they would reduce the ability of these clouds to trap outgoing long-wave radiation and thus optically and physically thin these clouds, which tend to have a net warming effect. However, there are significant uncertainties associated with SRM, including questions around the efficacy of each technique, the potential for unintended side effects, such as shifts in regional precipitation patterns or even localized warming, and a lack of clarity about their long-term impacts. Critically, there are no international laws specifically governing SRM research, and existing frameworks were not designed for these kinds of interventions. There are also major governance challenges, many of which Julie will touch on next, and I will then return to later through the case studies. Next slide, please. So since 2008, SRM field experiments across SAI, MCB, and CCT have gradually increased, with at least 5 attempted in 2024 alone. Over this time, several projects have been halted due to governance concerns, whilst private and even for-profit actors have also begun to enter the space, which are both listed here as independent SAI experiments. As field experiments become more frequent and visible, especially with new public funding initiatives like ARIA in the UK, the case for clear, transparent, and inclusive governance frameworks is becoming increasingly urgent. And with that, I would like to hand over to Julie Vinders for the legal analysis. So next slide, please.
Thank you very much. Good afternoon, everyone. Julie Vinders, I'm from Trilateral Research, and I'm leading the legal analysis as part of the Co-Create project. So I'll introduce some of the legal frameworks that are relevant and applicable to SRM research. And the purpose of this piece of research that's ongoing as part of the Co-Create project is looking at which legal frameworks are relevant and applicable, and therefore informative for an SRM research governance framework, as well as a sort of review of the adequacy of existing laws and legal frameworks, just as Ben mentioned, that these laws were often not developed with SRM in mind, but would nonetheless be applicable. So there are some overarching challenges that I'll introduce to you as well. Next slide, please. Yes, so there, even though there aren't any laws specific to the governance of SRM research, there are many existing legal norms and frameworks that are nonetheless relevant and likely applicable to SRM research. This includes substantive laws, so specific rights and obligations under different legal frameworks, as well as procedural laws, which relate more to specific procedures that might need to be complied with when conducting an SRM research activity, for example. as well as certain laws that are specific to scientific research, such as the right to freedom of scientific research, or the right to benefit from scientific research. We are looking at, we're identifying relevant legal frameworks at the international/multilateral level, as well as the EU level, and some legal frameworks are relevant at the national level as well. And this is all part of a general legal analysis of legal and governance aspects. And this piece of research is ongoing, and a final report will be produced in December later this year. Next slide, please. So when identifying what legal issues and what legal frameworks are relevant to SRM, it's essentially a matter of asking the who, what, where, and how, because only so much can really be said about SRM in general. A lot of things depend on the type of SRM activity, or the type of technique, or who it conducts, or where it is conducted, which might trigger different legal frameworks. So to get a comprehensive overview of the types of legal frameworks that might be relevant and applicable, we went through this exercise of asking essentially, well, who is planning to conduct the research activity, the researchers, is it public or private institutions, as well as who provides the funding, who authorizes the activities, but importantly also who might be affected by the research. And depending on the scale, and particularly the type of technology, if it happens on a more global scale, then potentially a very large group of people and communities might be affected by SRM research. Also things like who might be liable in the event of harm, and who owns the moral and material interests, or the intellectual property arising out of the research, and how do existing laws apply to this, and are they then fit for purpose, considering the certain unique aspects of SRM perhaps. The what relates to the different types of SRM. So as Ben already introduced, there are broadly three different types. There are some types of SRM which are a bit disputed whether you call them or classify them as SRM or not. So you could argue that they either are or they're not. But there are huge differences between the different types of SRM. So injecting aerosols and sulfate particles in the stratosphere might trigger certain chemical regulations and chemical laws, whereas marine cloud brightening involving spraying seawater in the lower atmosphere might trigger different legal frameworks, such as law of the seas. The where is very relevant. So if a research activity takes place within national territory or airspace, it might be limited to national laws. However, it's not only important to consider where the activity takes place, but also where the activity might have an impact. So if there are transboundary impacts, that is more likely to trigger international laws. Also, different laws might apply to activities in the high seas, for example, or in the polar regions. Might trigger Antarctica Treaty System or the Arctic Treaty System. If an activity takes place on indigenous land, it would trigger, it might trigger indigenous rights law, and any activity taking place in space. So SRM light shades in space, for example, would potentially trigger space law. And the how relates to how the activity or how the proposed activity would be carried out. And this might be subject to certain procedural requirements, such as due diligence, or related to consultation with affected communities, rules around access to information, or depending on the scale or the size, environmental impact assessments. Next slide, please. Thank you. So in terms of which legal frameworks that then leads to, that is becoming a rather long list, essentially, and then we're currently diving into what those different laws under those legal frameworks would mean in the context of SRM. So for human rights law, relevant rights might, or SRM might have an impact, for example, on the right to life or the right to private life, in a sense that it might, and SRM, if it's effective, it might protect those rights from harmful climate change effects, but at the same time, SRM can be considered risky, and if it results in a harmful environmental impact, it could also have a detrimental effect on certain human rights. The rights related to the freedom of scientific research are part of human rights legal frameworks, so those are relevant laws as well. Indigenous rights law relates, for example, to the conservation of indigenous land, any obligations to gather free, prior, and informed consent from indigenous communities, and representation and consultation. Environmental law is about a large body of law, which includes a broad range of different frameworks within it, essentially. So there's important legal principles, such as the precautionary principle, which has been invoked essentially both as an argument in favor of SRM and SRM research, as well as an argument to restrict SRM deployment, for example, or SRM research governance. No harm rule, so an obligation to prevent significant transboundary harm. Pollution regulation could relate to air pollution, water pollution, ocean dumping, etc. Waste and chemicals regulations, rules on environmental impact assessments, public participation and access to information. The Montreal Protocol, relevant for ozone protection, and environmental modification, which SRM would likely fall within the definition of environmental modification. Climate change law is relevant in the sense that SRM affects global temperatures, but it does not fit well within the framing of climate mitigation and adaptation categories very well. Outer space law, so any activities taking place in outer space, or law of the seas, in a sense of activities taking place on the oceans, or where it might have an impact on marine systems, and polar law as well. Rules on state responsibility, so obligations between states at an international or intergovernmental level, as well as national laws on liability, including civil and criminal law, and finally intellectual property law, so any moral and material interests arising out of research. Next slide, please. So what does that mean then for SRM research? As has been mentioned, there are no laws specific to the governance of SRM research, but that does not mean that it's an ungoverned area. And actually, a lot of these laws will be relevant and applicable. So any research team or state within which those activities are taking place will need to comply with those relevant laws. But a lot of that will depend on some of those specifics in terms of the who, the what, the where, and the how, in terms of which legal frameworks give rise to certain legal obligations. And just to note that there are a few legal institutions that have explicitly addressed SRM, such as the UN Convention on Biological Diversity and a decision from 2010 on geoengineering, which was recently reinforced, as well as the London Convention and London Protocol on Ocean on Marine Dumping, have addressed the issue of SRM. And some further recent developments within the EU, but also the UK. So the group of chief scientific advisors to the EU recently published a set of recommendations for the governance of SRM to the EU. The ARIA climate cooling program. There's a series of proposed state bans in the US. All of those developments are very relevant from a governance point of view and will impact as these things move forward. But having said that, there are some remaining overarching challenges from a governance point of view. So next slide, please. that we've identified so far, and that we will be investigating or diving deeper with this legal analysis that we're currently undertaking. So there's some ambiguities and conflicts that remain among definitions. So what constitutes SRM, and if a specific governance framework should be developed, how does it define SRM, and which activities or which types of SRM might essentially be on the edge of that definition, or perhaps fall outside the scope of the definition. Also relevant, what constitutes research within the meaning of law, and how is that different from deployment, where is the boundary or the delineation? What constitutes legitimate scientific research within the purpose or within the meaning of the law? There's room for interpretation of existing laws and principles. So I already briefly mentioned the precautionary principle, which has been invoked both as an argument in favor and against SRM. So what is the correct interpretation and application of the precautionary principle in the context of SRM? Or other principles like the no harm rule? What does that mean in the context of SRM, when SRM seeks to prevent dangerous climate change, but at the same time it comes with its own risks and potential harms to the environment? Limitations in the suitability of existing legal frameworks for the governance of SRM. So traditional regimes were developed maybe not with SRM in mind. So are they really fit for purpose? And are there certain things that are unique about SRM that might make it difficult for existing laws to be applied in an SRM context? The adequacy of governance of existing governance mechanisms and their effectiveness. So what is the correct forum or political forum to address or govern SRM? Is it at the international level? Is it the EU level? Is it the national level? Is it environmental law? Is it biodiversity law? Is it human rights law? Is it any one of those, or the combination of those existing fora? And finally, there's obvious tensions between the countervailing risks of climate change, which SRM seeks to address, but at the same time, the risks of SRM mean that we can't just look at one or the other without looking at the wider context. And the novelty of SRM means that we're in a unique situation where we haven't had this intentional alteration of a global climate system, which raises some unique governance challenges. So yes, that's the different issues that we are investigating from a legal and governance perspective. And I'll now hand back over to Ben to introduce some of the case studies.
Brilliant. Thank you, Julie. And yes, we will explore some of those legal aspects in the case studies shortly. But next slide, please. Before we move into the three case studies I want to talk about today, I think it's worth briefly sharing how these were developed. And so this part of the work draws on both a systematic review of past SRM field experiments and an expert workshop we convened at UCL in September last year. And so building on earlier efforts, particularly the 2014 Harvard typology developed by David Keith and colleagues, we worked with a group of researchers and technical experts to identify what plausible near-term SRM field experiments might actually look like across SAI, MCB, and CCT/MCT. And rather than focusing on speculative or far future interventions, we used a structured typology to identify plausible, as seen here, to identify plausible experiments that could reasonably be implemented within the coming years. These are assessed using scientific, technical, and regulatory criteria, such as detectability, reversibility, cost, feasibility, and alignment with existing environmental laws. And we also considered their potential to highlight different types of governance challenges. Next slide, please. To make this typology more tangible, We mapped the full set of 14 plausible experiments that we identified through the workshop, which included 6 SAI experiments, 5 MCB experiments, and 3 CCT/MCT experiments. And so what you see here is a log-log plot. On the horizontal axis is the total mass of material that would be released, and on the vertical axis is the downwind affected distance from the intervention release point. So SAI experiments are shown in blue circles, MCB experiments are shown in green pentagons, and CCT/MCT experiments are shown in yellow squares. And you can see that these span about 6 orders of magnitude in terms of material released, from a few hundred grams to 1,000 tons. For context, we've also included some benchmark reference points. And on the far right in black, you can see the 15 to 20 million tons of SO2, sulfur dioxide, that was released during the eruption of Mount Pinatubo in 1991, which led to a global cooling of up to 0.5 degrees Celsius for 2 years. And further still, the roughly 73 million tons of SO2 currently released each year from global anthropogenic sources. And then far to the left, on a smaller scale, the roughly 70 kilograms of SO2 that would be released from a one-way transatlantic flight. These comparisons show that even the largest SRM research proposals are still many orders of magnitude smaller than natural or already occurring anthropogenic events, at least in terms of physical scale. But as we will now see in the case studies, even small-scale experiments can pose serious governance challenges depending on where, how, and by whom they are conducted. Next slide, please. From the broader typology, we then developed 5 detailed hypothetical case studies, shown here on the map, designed to span a range of SRM interventions, from smaller scale, localized tests to larger scale transboundary scenarios. Each case explores different dimensions of SRM research governance, including the need for tailored regulatory frameworks, proactive risk management, and inclusive stakeholder engagement. Given SRM's global implications, these cases also reflect the potential involvement of European and international actors in shaping governance responses. By presenting a diversity of techniques, regions, and scales, including experiments set in the Arctic, the tropics, and global south, the aim is to highlight governance gaps and support more informed discussion around what responsible research might look like in practice. In the time available, I'll focus on just 3 of these: one CCT experiment in Arctic Norway, one MCB experiment off the coast of Angola, and one larger scale SAR experiment over Arctic Finland, which can be seen here as case studies 3, 4, and 5, respectively. Next slide, please. So this case study examines a hypothetical cirrus cloud thinning experiment conducted in Arctic Norway. The experiment proposes releasing up to 100 kilograms of ice nucleating particles, such as bismuth triiodide, into the upper troposphere during winter using drones. The aim is to encourage large ice crystal growth, causing the crystals to fall out of the cloud more quickly, thereby optically and physically thinning the cirrus clouds. This matters because cirrus clouds tend to trap outgoing long-wave radiation, so thinning them could reduce their net warming effect. Arctic Norway was selected for several reasons. Scientifically, the region offers ideal conditions, with cold, persistent cirrus cloud cover during winter, when there's very little incoming solar radiation, and a relatively low noise radiative environment, making it one of the more promising settings for testing the physical basis of CCT. Legally, conducting the experiment fully within Norwegian airspace brings it under a strong domestic regulatory regime. This includes the Pollution Control Act and the Nature Diversity Act, both of which enshrine the precautionary principle and require early-stage public engagement. Unlike conventional cloud seeding, which some jurisdictions regulate as weather modification, CCT operates at a different altitude and with a different objective, raising questions about whether existing frameworks are fit for purpose or whether new SRM-specific guidelines are needed for CCT. The case also explicitly reflects on lessons from the cancellations of the Scopex project, which was halted after failing to sufficiently engage with indigenous stakeholders in nearby Kiruna in Sweden. Here, proactive engagement with the Sami communities is not just a procedural requirement, it's essential given the cultural and environmental significance of Arctic territories and the values of traditional ecological knowledge in this region. Finally, this case illustrates the institutional layering that defines Arctic governance, with overlapping roles played by domestic governance, Sami parliaments, and broader regional bodies like the Arctic Council. Even small-scale research in such a context forces us to grapple with questions of legitimacy, procedural justice, and regulatory adequacy, issues that will only grow more complex as SRM research expands. Next slide, please. This case considers a hypothetical marine cloud brightening experiment conducted off the coast of Angola. It involves deploying a fleet of up to 10 vessels equipped with sea salt aerosol sprayers for a 6-week campaign, targeting persistent marine stratocumulus clouds. These clouds play a major role in regulating Earth's radiative balance, and the Southeast Atlantic is one of the most promising regions for MCB due to the prevalence of these cloud types and favorable atmospheric conditions. Despite its local scope, the experiment raises serious transboundary governance challenges. Although the activity would be confined to Angola's exclusive economic zone, the 200 nautical miles extending from the coast, the perturbed cloud systems could travel far beyond national jurisdiction, extending into the high seas and potentially affecting neighboring regions. While sea salt particles themselves are short-lived and dissipate within days, the perceived potential for atmospheric and climatic impacts still matters. Under Article 194 of the United Nations Convention of the Law of the Seas, or UNCLOS, states are obliged to prevent transboundary harm, regardless of who is undertaking the activity. So both UNCLOS and the United Nations Convention on Biological Diversity, UNCBD, also require environmental impact assessments and prior informed consent from potentially affected states. Even when physical risks are minimal, governance risks remain significant, particularly in the absence of clear exit strategies or mechanisms to pause or halt experiments if concerns arise. This case also reflects key lessons from recent MCB projects. The cancellation of a proposed trial by the Alameda City Council in California showed the consequences of insufficient early engagement. By contrast, the Great Barrier Reef MCB trials in Australia have succeeded in part because of a strong science-led dialogue with regulators, indigenous groups, and local communities, and because the experiment was clearly framed as part of a potential solution to reduce coral bleaching led under the umbrella of the Great Barrier Reef Foundation. Finally, this case highlights the importance of meaningful Global South participation in SRM research. Countries in the Global South are among the most vulnerable to climate change, yet have contributed the least to its causes. Ensuring these nations are not just sites of opportunity, but are actively leading or co-designing experiments is essential for building legitimacy, equity, and effective international governance. Next slide, please. Thank you. So the final case, this explores a hypothetical larger scale stratospheric aerosol injection experiment over Sorankylä in northern Finland. It involves releasing approximately 1,000 tons of sulfur dioxide into the stratosphere via high-altitude aircraft. And the aim here is to assess the dispersion dynamics to quantify the radiative effects under real-world stratospheric conditions and to validate global climate models. The experiment would take place at high altitudes, where the stratosphere is lower, around 9 to 12 kilometers, compared to the roughly 17 to 18 kilometers near the equator, making it more feasible using current aircraft. Although a 1,000-ton release is conceptually substantial for research, it remains very small compared to natural analogues. For instance, the experiment would release roughly 15,000 times less SO2 than the 1991 eruption of Mount Pinatubo. The environmental impacts of this exposed experiment are likely to be minimal. Any temperature change would likely be imperceptible from natural background variation, on the order of 0.001 degrees Celsius. And expected effects on ozone or precipitation patterns are also small at this scale. Nevertheless, scientific uncertainties remain, particularly around aerosol microphysics and potential feedbacks. While significantly greater uncertainties remain regarding the environmental consequences of full-scale deployment involving millions of tons of SO2, experiments like this could help to improve our understanding of aerosol behavior in the stratosphere and refine these climate model projections. That said, even limited physical intervention can raise substantial governance challenges, especially when particles disperse rapidly across borders, as they would here, likely entering Russian airspace within hours to days of release. Even if the physical impacts are small, the political and legal implications are significant. One of the central governance challenges in SRM is defining who the relevant stakeholders are when materials are injected into the stratosphere and dispersed either hemispherically or even globally. Are they the communities beneath the release site, or does it include everyone potentially downwind of the aerosols? And beyond that, what constitutes meaningful communication or consent in such a context? Whilst Finland is permitted to emit up to 30,000 tons of SO2 annually under the Gothenburg Protocol, repurposing that allowance for intentional climate intervention would likely trigger legal scrutiny under several regimes. These include the Convention on Long-Range Transboundary Air Pollution and EU frameworks such as the Environmental Impact Assessment Directive and the Ambient Air Quality Directive. Fundamentally, the scale of this experiment also tests the boundaries of the aforementioned UNCBD's small-scale SRM research exemption, a term that remains undefined in international law. This intervention would almost certainly be perceived as exceeding that threshold, despite only releasing as much SO2 as is currently released through anthropogenic emissions worldwide roughly every 7 minutes. The case highlights how governance challenges and perceptions of scale remain unresolved and contested in the SRM space, particularly when experimental activities cross borders, engage multiple legal frameworks, and raise questions of procedural legitimacy. Next slide, please. So that is the case studies. And just to note, all of the co-create documents and manuscripts that Julie and I have mentioned, they can be accessed here. And with that, I would like to hand over to Jesse Reynolds for the expert reflection. Next slide, please.
Great, thanks for the opportunity to speak. I'll keep my observations brief so that we can get to Q&A. I will say that my comments do not necessarily reflect the positions of the Degrees Initiative where I am employed. My comments are not coherent. They're a bit of a grab bag, but hopefully will stimulate some conversation or thought. First, the environment in which SRM is being researched is rapidly changing. That's been evident for about 2 or 3 years, with increasing number of international authoritative reports, greater funding from public and philanthropic sources, apparently a new wave cohort of upcoming outdoor experiments funded by the ARIA program in the UK, and the introduction of 2 very different commercial actors into this issue area. My second set of observations concerns governance, and many people have said many things about governance, but what's on my mind lately about governance is a recommendation to pause and think about ways in which SRM is normal, not abnormal, where I think there's a temptation to immediately run to. To give an example, perturbative environmental research is a regular feature of environmental science. Likewise, there are ways in which governance is directly or indirectly applicable. Julie touched on many components here, but to the extent it is applicable, common tenets of domestic regulation, such as environmental impact assessment, can go a long way towards understanding potential risks of outdoor activities. And to be clear, this isn't to imply that there aren't governance gaps or that SRM is fully a normal, typical activity, but just to pause and reflect where we're at. Third, I'm quite encouraged by the development of these cases of outdoor experiments. For years, we've heard about potential outdoor SRM experiments in sort of a very general, way, but to have these 5 cases where we can sink our teeth into will be very useful for co-create and beyond. Of course, one can quibble about the choice in general and of the details, but they will definitely be useful. Fourth, on the topic of emergency, which was mentioned briefly, I think Ben mentioned it briefly early in his comments. There is increasing framing of climate change as an emergency, if not a crisis. I would recommend that caution is exercised around the extension of that framing to the potential use of SRM. It could indeed be a, in case of emergency, break glass tool. but likewise, it may have more utility and be more amenable to consensus as a ongoing contribution to the management of climate change risks. Finally, my thinking is drawn to potential practical next steps within SRM research and governance. In an area that is contested as this, of course, there's much to disagree about, but perhaps there are areas in which many contributors can find common ground. I'll name a few. First, research in the European Union is lags surprisingly behind the Anglosphere in particular. This is an area where as a project that we speak to the European Union, of course, on the governance of research, there may be space to think about research activities itself. Second, I would be, this is one area where I definitely do put on my degrees initiative hat, and that is I think that there's near universal consensus that the Global South deserves a full, informed, and independent seat at any international governance dialogues, and as such, capacity building is an imperative. Third, authoritative international assessment would be beneficial. That has been lacking up to this point. There's been brief investigations by the IPCC, and reports such as UNEP do not quite rise to the level of a true scientific assessment. I think such activities could go a long way. Fourth, transparency is sort of a mantra of SRM governance conversations. And our friends at SRM 360 have recently published, for example, a funding database and a registry of researchers. Those are steps in the right direction. We can also think about, for example, public pre-registration of experiments, both modeling experiments and outdoor experiments, to reduce the potential of reverse engineering results. And finally, perhaps are steps towards developing monitoring capacity for outdoor SRM activities. It's my understanding that is a growing conversation as well. I'll conclude my grab bag there and look forward to the questions and answers.
Fantastic. Many thanks, Jesse. Yeah, so let's open the Q&A session right now. Please feel more than welcome to share your questions in the Q&A chat. Maybe we'll just give it a half minute very quickly, think of some questions. Julie, as you know, I already have a question for you. That would quite interested to hear your thoughts on the matter. So I'd like to hear your thoughts on what are the prospects and challenges of establishing an international agreement, a binding international agreement on SRM research.
Yes, thank you for the question. Yeah, I think there's some goals essentially for international agreements on SRM research and or deployment. I think in particular some more recent recommendation, particularly from the group of chief scientific advisors to the EU, call for a moratorium on the deployment of SRM whilst recognizing a need for small-scale experiments, for example. So yeah, I think these suggestions and these recommendations, they come from this concern of a slippery slope. So this fear that engaging in SRM research will gain such traction and momentum that it will inevitably lead to SRM deployment without adequately considering its risks, for example. So this is where this recommendation is sort of rooted in that if we say in advance, okay, let's put a halt on deployment and then focus on developing a governance framework for SRM research, then we have that barrier in place so that we address the slippery slope concern essentially. Which yes, I think might be justifiable, but whether that may result in an international binding agreement, I think with the current political climate and environmental lawmaking prospects, I think that it's quite difficult to get any form of, or it would be very difficult to get any form of agreement at an international level. I think it's a highly contested area, and even just looking at climate law in itself, and the Paris Agreement discussions, participation in the Paris Agreement, and particularly of key countries such as the US withdrawing from the Paris Agreement. I think any prospect of developing binding agreements on SRM will be challenging. Having said that, though, that doesn't stop countries that take that position to advocate for the non-deployment of SRM, at least at this stage, and particularly at an international level. But I doubt that it will be feasible to achieve a binding agreement on this. But perhaps others have more thoughts on that or other reflections.
Ben, I saw you answered a question from Jeff Sutton on whether we study land albedo modification. Would you like to maybe share a bit your
Sure.
answer
So
with everyone?
I guess some people might not have seen the question, but yeah, Jeff's got a good question, which is, do you also study land albedo modification? And so my response to him is, well, thank you for the question, Jeff, but we do consider sea ice thickening as one of the case studies that is taking place in Cambridge Bay in high Arctic Canada, and we do that in one sense to look in particular at the Nunavut Agreement as a governance framework, because there are many positive aspects of inclusive governance and ensuring and including Indigenous perspectives in that. In the Nunavut Agreement, which is a nice example to look at for other governance frameworks, perhaps to sort of incorporate elements of it. In general, though, for the Co-Create project, we mainly focus primarily on SAI, MCB, and serious cloud thinning, mixed phase cloud thinning, because these are considered the most plausible experiments, most affordable, most plausible experiments to be sort of happening in the foreseeable future. And more to the point, these are the kinds of experiments which are already taking place, as that graph I showed a couple of, about 20 minutes ago, that showed that these are the experiments which are already taking place. So another one which is becoming more of greater interest is of course sunshades and things like that in space at Lagrange point 1, but those are still probably they're not as feasible right now. So they're not considered with the same amount of gravitas as the other examples.
Thank you very much for sharing your answer, Ben. I see that there's a question posed for Jesse. Is there an example of applying pre-registration into academic research involving climate or environment? Pre-registration seems to have only been widely applied, accepting in medical research.
That is true. I'm not immediately aware of the adoption of pre-registration in climate and environmental sciences more generally. I'm mostly aware of it in biomedical research as well as psychology. And perhaps there's justified reasons for that difference. Perhaps it's just one of those, path dependencies of the way that history played out about where ideas originate and where they get picked up. Nevertheless, like some areas of biomedical research and psychology, there is no shortage of contention around SRM, and including concerns around groupthink, for example. Is it a small community that's unduly self-referential? Is there a slippery slope? Could there be a slippery slope from research to onward to development and potential use? And I'm increasingly of the mind that pre-registration, particularly public pre-registration, could go a significant step towards addressing those challenges.
Ben, I'd like to share a question with you, if that's okay. So it's quite related to marine cloud writing specifically. I'd like maybe if you could share some thoughts on what kind of governance structures are needed for those cross-boundary impacts. What are the main responses that we could do for when atmospheric effects cross international waters or go into neighboring regions? You probably touched about it on the presentation, but at least to me, it sounds like a really interesting consideration into this matter.
Yeah, okay. So marine cloud brightening is very interesting because of the fact, as Julie nicely sort of highlighted, the fact that the UN clause is a really important legal framework for that once any of these effects do escape from sort of the national waters of an area, so outside of the exclusive economic zone. And so all current sort of marine cloud brightening experiments which are taking place, they're all done within national boundaries, sort of in Australia. That's what's happening in the Great Barrier Reef. But if you were to scale up these experiments, it becomes more complicated. I'll actually pass over to Julie to answer that, I think, if that's okay, because I think she's better placed to focus on the UN.
Yeah, no problem. I mean, I think you addressed that question quite well. I mean, I think what's important to know with UNCLOS is that it also applies to the atmosphere above. So any impacts, it doesn't just relate to the body of water, but also any impacts on the atmosphere above. So yeah, transboundary effects might trigger rules, and under the Law of the Sea Convention. Yeah, I don't know if that answers the.
To me, it seems that it very much answers it to a very satisfactory extent. I've also seen we have a final question, perhaps, before we move into concluding remarks. Is aircraft available for polar SAI, and how long would it take to have tropical SAI aircraft? Happy to. Feel free.
Happy to jump in briefly on the polar element, and then I think Jesse looked like he might want to nod on the tropical stuff. But a colleague of mine from UCL, Ali Duffy, has just written an excellent paper on the potential for polar SAI with essentially slightly modified 777 aircraft, which we currently have, that these could feasibly in the near term be able to do these large scale releases of material, as these can fly at the sort of altitude above the tropical pores where these materials could be released more or less in the near future. And so, for example, a 777 has a sort of potential weight capacity, a load capacity of about 100 tons it could carry. So you can imagine, for example, that 1,000-ton example I had from Arctic Finland, that would involve about 10 planes, to do that release. So it is feasible. And the thing is, though, what they focus on in that paper as well, which is quite interesting, is the fact that the efficacy of releasing material for stratospheric aerosol injection in the polar regions is about as a ballpark figure, about a third of as effective as if you were to do that in the tropical regions. So it's not quite as effective, but it's a much nearer term sort of possibility than tropical SAI, primarily because of the fact that the tropical pores in the equator is about 18 kilometers in altitude. So you need to substantially increase the actual ceiling of these large scale planes. But I can see Jesse's nodding as well.
Yeah, it might be useful. I mean, I'm not sure exactly who our audience is. The session is oriented somewhat towards an introduction, so it may be useful to back up a step. The interest is in the stratosphere because more or less it's above the weather. If you're below the stratosphere, we have the troposphere, there's rain, there's wind, or there's more wind at least. And so any injection of aerosols there is rapidly precipitated out. And indeed, the boundary between the troposphere, where there's weather, and the stratosphere, where there's much less activity, varies significantly from near the poles to the equator, where it's roughly double. I think, Ben, correct me if I'm wrong, but you're talking double. So existing aircraft can get into the stratosphere reasonably well near the poles. Now, in the long run, some sort of global deployment of SRM would have particular interest in being near the poles because the distribution of the particles in the stratosphere naturally goes poleward due to the currents that do exist in the stratosphere. However, at the research stage, we're not interested, scientists would not be interested in cooling the planet. They may be interested in, for example, how particles behave in the stratosphere. And it's my understanding that that can be observed reasonably well in the high latitude subpolar stratosphere. So that's an area where there is some work. There was a really fascinating session at the recent Degrees Global Forum. We'll soon have the audio online on the website about what the steps are towards such outdoor experiments, aircraft, and even the early years of potential deployment. So if you're particularly interested, keep your eye open out on that.
Great. Thank you so much for sharing, Jesse. So we're about at time, so I think it's best if we close off at this moment. Unfortunately, thank you all so much for coming again. I'd like to point out that this is the first of the Co-Create webinar series, so there's many more events to come. There's also a Co-Create seminar coming by the end of the month, where you'll be welcome to engage in a more open discussion with everyone on these topics. We very much welcome you to join for this and to keep out on social media for the announcement, which will be coming soon. Also recommend, as you can see on the slide, to join the stakeholder forum, the Co-Create stakeholder forum, where you're able to join other experts from within and beyond the Co-Create consortium as we share news of recent topics in the field, recent developments in research, as well as some sneak peeks of our research and recent deliverables and news of upcoming events. So very much welcome to check that out and join us for the coming discussions. Thank you very much and have a lovely rest of the afternoon.